Okay, so what I was telling here is that in case of 2D crystals, you observe two types of packing. One is known as square packing and another is your hexagonal packing. Okay, in case of square packing, the void is also have four distinct edges. So this is called also square as a square void. Okay, and in case of square packing, if you think this as your central atom, okay, then the rest it has four neighbors, that is it has a coordination number 4. But in another case of two-dimensional packing, where you can think that these two layers has just shifted by a small amount, okay, so it makes an AB kind of arrangement. If you see very closely here, is that the upper layer and the down layer, okay, the upper layer and down layer, they form a triangular void. Let's take a very close look. So what we will found, the upper layer has here, in case of the upper layer, has a your upside directed triangular void, whereas the lower layer with the upper layer has a downside directed triangular void. Okay, so it contains a triangular void. In case of this AB arrangement, it has a triangular void, and this triangular void is in first row it is upside directed, and in the second row is the downward directed. So it is like upside downside kind of arrangement. Okay, okay, now if you think this as a central atom, okay, then it has 6 neighbors surrounding it. Okay, so it is known as hexagonal packing, and see, indeed it forms a hexagonal structure in its coordination shell. Okay, now what we talked about so far is one-dimensional lattice structure with closed pack structure and two-dimensional closed pack structure. Now let's see what happens in case of three-dimensional structure. Okay, one thing I want to tell you here, see, this chapter, this closed packing is a very much abstract thing. Okay, so what you guys have to do, you have to just imagine, just close your eyes and imagine. Okay, acha, see, let's say in case of three-dimensional closed packing, three-dimensional closed packing. Okay, so what can you observe? Let's draw that the first layer and the second layer. Okay, the first layer and the second layer are just lower to each other. Okay, just let's see, let's draw one way of arrangement. This is one. Sorry, actually I needed to draw this, so it's actually takes time. Acha. So in case of 3D closed packing structures, 3D is what? Nothing but your 2D with 1D. Okay, like what we said, this is our 1D arrangement, this is our 2D arrangement, and this 2D, above this 2D you are putting another one dimension. Okay, so it becomes a layered like structure. So let's say in case of the first case, where all the your elements or all the atoms are in same positions, they are not shifted, right? So what was the case here? In 2D it was like this. So in case of 3D also, what will, this is what type? This is A type, right? A type. So in case of three-dimensional, what will happen? Same. just above this, another one, another layer, right? So one void will be surrounded by eight particles. Eight atoms. So it's like this. You can say the cubic. If I consider the example, cubic. In this case, okay, all the atoms are in this type. So if you take the closed pack, so what will be observed? This now what is happening? You are basically replicating the cube in all the directions, right? Now this replication leads to this AAA type of closed pack structure, and it is usually generally observed in normal cases. But there is another type. Okay, so in the second case, where the 2D, in case of 2D, what you have done, you have just shifted the second layer by a small unit. And that shifting, you are basically the two layers. This is your first layer, and this, the red one, is the second layer. Okay, second layer. Now if you see very carefully here, and don't worry, this point I would recommend you should open your NCERT book or any book you use for this purpose. This is a very beautiful picture is given there. Okay, so if you see very carefully here, is that this part, if I draw, okay, so this black one is the upper layer, black one is the upper layer, and the red one is the lower layer. Okay, so they are just and over each other. How? Now the void of the black layer is compensated by the red layer. Okay, so let's say I am talking about this region, this part, if I draw, think about, so how it will look like? This, okay, and your red is here, see very carefully. If you have, this is a void, this is the void, okay, very carefully, this kind of arrangement, if you see, okay, this kind of arrangement, what leads to? This actually leads to a tetragonal arrangement with the central atom here, right? It's like a tetrahedral arrangement. If you think, you heard about the silicon structures. The silicon structure, how will you draw? Let's say if you have a silicate kind of oxygen. Okay, so what you do? This silicon you put as a point, and this like, see this kind of structure. So here also you will find this is central oxygen with this central, this red one, and you will find three different substitutions there. And if you say that this, that means this void is surrounded by four atoms, and this kind of voids which surrounded by the four atom centers is known as your tetrahedral void. Okay, this is known as tetrahedral void. So how many tetrahedral voids are there? I am drawing the tetrahedral voids by black. So this is a tetrahedral void, tetrahedral void, tetrahedral void, tetrahedral void, tetrahedral void. Okay, so other than, so there is another tetrahedral void here, tetrahedral void here, tetrahedral void here, tetrahedral void here. Other than the tetrahedral void, you will see another type of void. Let me draw here. So what is that? If I consider this part, this 3 red and this 3 black, what is happening here? Careful. This 3 red black and your anyways they should touch each other. Okay. If you see here, this void, this particular void is surrounded by 6 atoms. 1, 2, 3, 3, 4, 5, 6. 6 atoms, okay? And if I have a model of tetrahedral structure, octahedral structure here, if you see, it's a model 6 atoms. Now think it's in this way. Okay, yeah, this way. This way. Think in this way. See, these 3 are the red one and these 3 are the black one. So this is a void region, right? Now, so what is the void region is now? This void region is surrounded by the 6 atoms. So this kind of voids are called as octahedral voids. Octahedral voids, okay? Acha. Now, what? So in case of a lattice, okay, it's generally observed is that there is a mathematical sorry okay. Acha. There is a mathematical way to calculate. You can see that for a solid having n lattice points, in lattice points, they will tell you to calculate the number of tetrahedral voids and number of octahedral voids. The number of tetrahedral voids will be equal to your 2n, whereas the number of octahedral voids will be n. Okay, so I will repeat just what I said here. First, what we talked about, the one-dimensional lattice closed pack structure. Next, two-dimensional closed pack structure. Now what we combine then? The two-dimensional with the one dimension. Now combining that, we get the 3D closed packing structures, and these 3D closed packing structure constitute 2 types. In case of first type, it is AAA type of arrangement. That means all the lattice points are in the same plane. So you will get that each is a highly closed pack structure, and it will have a cubic kind of arrangement. If you replicate this cubic structure by many times, you will get this AAA type, because all the atoms are in the same. But there is another case where the 2 layers, okay, in the each layer, the lattice points are shifted by a small amount, okay, and small amount is basically here the shifted by the amount of the radius, okay. And if these kind of 2 layers combine with each other, okay, then each of the layers will follow the next layer will follow the previous layer void region, okay. Now from this part you will observe 2 kinds of voids. Number 1, in one void where you will find the void is surrounded by 4 atoms, and that kind of voids is known as the tetrahedral void, okay. But and there is another void which you will find these voids, I am marking it by red. Okay, these kind of voids where the voids are surrounded by 6 atoms, okay. So and these voids are known as octahedral voids, okay. So if in a solid there is an n lattice point, by mathematics you can calculate easily the number of tetrahedral voids will be 2n and the number of octahedral voids will be n, Okay.